All right, good morning and afternoon, everyone. Welcome to this month's webinar series for Building Smart USA technical and industry topics. For this month's series, we are presenting on no delays, airport data connections from BIM to GIS. Myself, Posh Supupramai, is with CNS Companies. I am the Aviation BIM Services Manager, and I co-lead the Airport Room BIM to GIS Working Group for Building Smart USA. And joining me is David Alvarez with Esri. He is the Senior Product Engineer and also co-leads the working group with me. All right, moving on to presentation, Airport Data Connection from BIM to GIS. So the first thing that comes to mind when someone mentions BIM to me, I picture a model, something data rich. And when someone mentioned GIS to me, I picture a map. So why do we want to go BIM to GIS? And that's because when we combine the two, we get a data rich map. And as we go through this journey of the connection of BIM to GIS, I just want to start off with a quick example of something that most of us has gone through or will go through in our lives. And that is airport travel. So in my case, I live in South Florida. The first thing I do when I'm headed out to airport is I open up a map to my local airport, Fort Lauderdale International Airport. First thing I do before I leave my house, even though I've been to airport countless times, I just want to make sure I take the fastest route. Those of you who's driven in South Florida before, traffic can lead up to 30 minutes to an hour. But a Google Maps gives you a data-rich navigation from point A to B, and it's going to give you the fastest route, avoiding traffic and accidents along the way. So that's the data within the map. So once we get to the airport, even though we have our ticket on our phones or printed out, we still check the data on the flight information screen to make sure, our flight is saying on time and the gate is where it's supposed to be. So once we see the gate number, we're gonna look at our airport map and find out where we have to go, if we need to use the restroom or grab breakfast or lunch before the long flight. We know where those restaurants or restrooms are. And some of you might be like me where you get paranoid. I don't know why, I just always go to my gate first and check that it's there and that the flight information on that gate screen matches my flight information. And all of that is so that we have no delays and a smooth takeoff. I just want to plug last month's webinar series. So we mentioned smooth takeoff. Scott Yates had presented on the critical role of asset data within the ORAT system. So check that out if you missed it. So just a brief breakout of what David and myself have been working on in our efforts for the BIM to GIS working group. We work with the Building Smart International chapter to further the development of established standards. We work in connecting data and models from BIM to GIS. We work with US airports on the development and deployment of these standards. And we really want to understand from these airport entities what airport specific aspects are in consideration for digital twin. And really, we want to promote the seamless integration between IFC for airports and GIS. On the agenda today, we will go over why we're going BIM to GIS. We'll showcase a workflow for BIM to GIS. We'll talk more about Open BIM in GIS and close it up with the future of airport IFC. So why should we connect to GIS? And I just love this graphic. on the screen here. Most of you have seen a similar graphic or this graphic itself, but as we start in the lower left quadrant in the planning phase, we're starting in the GIS end on a map or just planning maps, right? And then once we get into design, we introduce BIM. And we're adding data to our models and we go into building it and updating those BIM models into operation and asset management. And then as the life cycle of that infrastructure relapse, we go back into planning stage again to complete that life cycle. So why are we pushing BIM into GIS? So we can have real-time data, and then we can visualize these data on multiple maps. It's going to help us analyze and provide decision-making processes. And the more information we integrate into GIS, the more accurate depiction of the airport interconnected system will be. Taking this from the Building Smart International BIM to GIS Working Group, these are the three core components of why BIM to GIS is important. Visualization, spatial analysis, and collaboration. And just to highlight some use cases for BIM to GIS, stakeholder engagement, construction project management, asset management, reality capture. We can easily access and visualize the infrastructure once we have integrated into GIS. Moving on, moving on to our case study of BIM to GIS. For our airport model case study today, we have the Syracuse Hancock International Airport Terminal Expansion and Renovation Project. The objective for this BIM to GIS workflow is so we can show that we can easily integrate BIM models in GIS, and we can use this workflow for future projects. The BIM models used from the project are Autodesk Civil 3D, Autodesk Revit, and IFC exports of those models. Another key component to this case study is to show that whether it be a Revit import into GIS or an IFC import into GIS, we're getting the same data. So we start off in the BIM to GIS planning phase. We want to see what's our end goal. In this case, we have completed the project already. So we're looking at a static model. We're just looking to visualize the model or query or manage it. But there is a dynamic route that we can go through where IoT sensors can be introduced to get live up-to-date data for that BIM model integration. We start off with the data storage for the BIM model. In this case, we have everything stored in Autodesk Construction Cloud. The IFC, the Revit, and the Civil 3D model are all in there, so we can easily access it in ArcGIS Pro. Before we go into the process of BIM to GIS, we need to understand how that data is broken down once it gets integrated into ArcGIS. So on the left side, you have your BIM file work structure. So with Revit, we have families. Once we integrate that into ArcGIS, they become building layers, and those families become attributes. So still all the same data, just broken up into different categories. Essentially, this is the process where from left to right, we have the Revit or IFC imported into ArcGIS Pro and becomes 3D layers and broken down into categories shown on the screen. Once we have our BIM model integrated into imported into GIS, the most important part is we want that model to be accurately depicted into maps. So geolocation is important. In this case, we already have all the georeference set up for the coordinate system of the BIM models. So we just imported the PRJ file. But later on in the presentation, David will go over other ways that we can geo-reference BIM models. So once we have everything in ArcGIS Pro, we want to share that to other audience on ArcGIS Online so that they can visualize, analyze, and explore and collaborate with the models. And we can do so by publishing it as a web scene and uploading it to ArcGIS Online. And we can add, the important thing about GIS is we can add background data. So we can add in elevation data and add in OpenStreetMaps to just have a better depiction of the surrounding environment. And this is just to showcase. On the left side, we have the web scene export from GIS with the IFC model. And then on the right side is the IFC model from the Autodesk Construction Cloud storage. You can see the data is all the same, just broken out a little bit differently. All right, so I'm just going to do a recording of what it looks like for the Revit model once it's exported as a web scene in ArcGIS Online. So we start off with GIS map. We're able to, and this is all web-based. We're able to navigate through the model. As we zoom in, the model renders out. We're able to pan around, spin around the model. I'm gonna zoom into the front door real quick. We're also able to click on different entities within that BIM model. So you can see that it is a door. So moving on, we're gonna show the exact same example, but now with the IFC export to web scene. So here we have the published web scene with the IFC imported in. Open the scene viewer. I'll find my way to that same door. We can click on it. Same data as the Revit model. So you can see everything looks the same from the IFC export versus the Revit. So we're not losing anything along the way. And the great thing with having BIM and GIS is we can collaborate and turn on different model entities and change the ground transparency of the maps. So we can look at the underground piles and the storm network. We can also change the different base maps. I don't have a flood map on here, but if you had one, you could put that on here as well. Changing back real quick. We can also do shadow analysis. So I'm gonna go to today's date, June, we're gonna be 2023. We can change the time from sunrise to sunset and see how the shadows are cast on the building. With the BIM model in GIS, we can also do quick measurements of the building. So right here, I am going to measure this wall. We can also do quick cross sections of the building itself. So I'm going to change it from the flat plane to vertical plane. select. Now I can drag. I can also change the view of that cut by expanding the box itself. So we can do quick collaboration and break out into the building model. So here's the lobby of the terminal. Out, we can zoom out. And we can also set preset views. So you can see I had set different views for the model. So here is the TSA check, and then we can also change this toggle on and off disciplines and categories. So we just want to look at certain elements, we can toggle them on and off. And as you change the presets, those disciplines and category will change with it. So for collaboration, this is a great way to set your presets for stakeholder engagement. I'm going to pass it on to David to talk about Open BIM in action.
Thank you, Posh. Good morning or afternoon, everybody. So why do we want BIM data in GIS? First of all, infrastructures, as Posh mentioned, can be placed into larger real-world context. In this case, infrastructures, I mean an airport, a building, a bridge, anything that is built. Also, using GIS, we can create deeper analysis of the data during the life cycle of the infrastructure, even using a very generic model to a very detailed model. And also, it gives us a common data environment for future integration with digital twins. So before we go and do the integration between BIM and GIS, we have a hurdle that it was units and coordinate systems needed to match. What that means that basically if your file was in inches and your coordinate system needed to be in inches, which that creates a big issue. So because the units were mixed, sometimes you get your building or your infrastructure all shrink or all elongated. But after Pro 2.9 and later, now that issue, that limitation that we had is not present anymore. Now you can have a mix. If your file units are in millimeters, you can have a projection in feet or meters, and vice versa. So now that this hurdle has been passed, oh, there you go, next one. We can now focus on geolocating the building model. So what that means, we're going from a unknown location to a known location. And we have done that. Sorry. We have done that. And if you're using IFC for X, I recommend you take advantage of the IFC projected CRS and the IFC map conversion. That means basically if the file was exported and it was created in 4X and those values are populated correctly. But I mean populate correctly, yes, you can populate those values incorrectly. But if they're populated correctly, that means that when you read it in ArcGIS Pro, the file will land in the correct location. So you don't have to do any process if you're taking advantage, and that only applies to 4X. Now, for here example is you have the same file, you got your IFC 4X, and you have your Revit file. As you can see, what the arrow points out is the IFC file is reading, or basically ArcGIS Pro is reading the information in relation to where that file is located and which projection is using. So that's the benefit of using 4X IFC. With the Revit file, basically you have to go through a process to locate it in the right location. So we created, because not all the files are exported in 4X, or not all 4X files are leveraging that information, we created a workflow that we divided into. So the first part is the preliminary part, where basically, Posh, would you click next? Okay. The first part, so basically the first two windows on your left are the preliminary location. So it's two simple questions. It's what projection are you going to use for your file? And will you basically input an address where the project is location, or the infrastructure location? This basically will place the file close enough to the correct location. But then you have the part two. You already place it in the approximate location where it should be. Now you're going to use the final part two, which is a GP tool, or sorry, not GP tool, a menu that will have some tools. You have your move, your rotate, elevate to ground, which are basically used to tweak and rotate and just basically your ground level of the, let's say, a building, it's 5 feet above the terrain. So you can use those tools to basically match your terrain and do the final adjustment. So now that you have your final adjustment, let's go and summarize a little bit. So you're going from an unknown location to an approximation location, and you're using your validate position. From there on, you have your final adjustment, which is basically the tools that you're going to use to place it in the exact location. And now that you have it in the exact location, now you can basically leverage GIS. So bring all your ancillary data, all the data that you want to use to do analysis. And at the same time, all that data plus the digital model can be shared to users on a desktop application, or you can use it to multiple users on a web application. Why do we like IFC? It's flexible. As you can see here, this is an example of an interchange. And you can see that the user that created this IFC file added some additional custom attributes that are needed for the user. If we now go to ArcGIS Pro, same BIM that was selected on the prior example, now you can see here that we're reading the geometry plus the attributes. Next slide will show you basically that there's a few that I highlighted that you can see that the attributes are in the IFC. They are also read by the ArcGIS Pro. So let's talk a little bit about kind of the workflow that Posh mentioned, but let's do it a little bit more detail. So you have your IFC and Revit files, and let's make the assumption that they're already georeferenced, and you bring them in Pro. You have two options. You can go publish the web scene with the building scene layer, or you can create your SLPK building scene layer package. The SLPK is basically, it's a way of packaging your digital model into a different format that is read by ArcGIS Pro, Enterprise, or ArcGIS Online, or even GeoBIM. So basically, in that case, you're just packaging the digital model. Now, if we go the upper route where you're publishing the web scene, you can go to a static, so your data is not dynamic, or you can go what we call cache online, and this applies to ArcGIS Online or Enterprise, where basically your data is dynamic. You create feature services. The benefit of the second one, when you cache online or basically you have feature services, is that you can use those feature services now and expand the amount of information that your digital models can have. Because now, because I have those feature services, I can now connect to a SAP system, for example, for work orders, or I can connect to Maximo. So that gives me now the additional capabilities that I'm not just using my digital model, my geometries and the attributes that were created, but now I have additional information that I can use to make decisions. We have at the bottom one that I just want to highlight, geodatabase. So there's another workflow that I didn't mention here, where you can use your IFC files, your Revit files, and convert it into a geodatabase. And why would you do that? The reason that you will do that is sometimes when the data is created and when the data was exported to IFC or even from Revit, things don't show up where they're supposed to be. So sometimes you will have elements that, let's say is furniture, but the way that the designer created the element, they use a generic model in the case of Revit. So when you exported it from the IFC perspective, you're getting a building proxy element. But when you're trying to do analysis and work with the data, or let's say do an inventory of your furniture, it's not going to be present because it's in the generic model. So if you convert it to a geodatabase, you can tweak, because it's already in a geodatabase, you can now use that geodatabase, manage your data, slice it and dice it the way that it will fit your schema, what you want to do, how you want to move your data. And at the same time, you now have the capability of, let's say, a key attribute that you want for your asset managed systems. When your IFC or your Revit file was created, it's not present. I can use the data on the geodatabase and create that additional attribute and populate it, let's say, with my asset ID. So now I can link that asset ID to my CMS systems, and now I have a way of managing the data. All that information that I had come from my IFC, now I have a way to add another benefit to it. Next slide. Okay, so this is my part. I'm gonna share my screen, a video. So I was gonna try to do an airport, but I didn't get any data. So I'm gonna go through kind of a bridge example of leveraging IFC and put it in relation to real world context and how an additional GIS data will help us make decisions. So let's start. Basically, this is IFC file. It's a bridge, and I'm using different viewers. So showcase that it doesn't matter which viewer you're using, you're getting the same information, which is the same information that you get in ArcGIS Pro. So the end goal is to reproduce that scene. So you got, I created all the buildings that are in the area. I got bathymetry data from the Corps of Engineers. I got LiDAR data. So I classify it using tools from ArcGIS. I bring NOAA data for my hurricane category 1, 2, 3, and 4, and how it affects the surrounding areas, sea level rise. Now this is the building that we brought in. Here we can see the relation of the British building with the, let me just pause. In the prior one, you saw the building in relation to the bathymetry. Let me just move it a little bit back here. You can see the contours. So if you have to do the inspection of the piles here, you will know the surrounding area. or if you can do a survey of the canal of the channel, often enough you will be able to see if there's movement of earth around the piles, and if you still have to worry about it. So let's move to the attributes. So when I highlight here, as I said before on my example, you got your IFC data and you got your primary key, and you can use it to link it to another system. In this case, I'm linking it to a system that gives me a rating to each of the elements. So in this case, that is still BIM is a 3. The peer is a 6, and this frame box is an 8. So having that data like that, I now can basically change my symbology of the data, and I can visualize the elements based on the rating. So the ones that I need to pay attention to are the red ones. Those are 3 or below. Those are critical. I got my data in Pro. I got all the information that I needed. Now I can bring that data to the web. As I mentioned before, you have 2 routes. We're going through the above route of the diagram. We're just going to create the feature services because we want to update and leverage those services to create a dashboard. So here's my data. All the data that I showed before in Pro, it's online. You got your LiDAR, your contours for the bottom of the channel. You can see here, this is the hurricane impacted area. So the kind of wash green is category 1. The bright green is category 2, yellow 3, and red is 4. So if I'm looking at the transportation side, the bridge is fine here, but basically here you have a little bit of a bottleneck. So if there's an evacuation, that could be an issue in the future. And especially here, it's not related to the bridge, but basically here on this road, it will be affected. So let's move to the next one. You can see here, basically, I show you this is rating 3, which is my concern. Now let's go another inspection. So we have this BIM here, but at the same time, now I can link to other systems. So I have a picture that was taken that it will assign why that bridge, that way that BIM has that rating. Here's another one. That one is a 6, and you can see this is the embodiment of the bridge. At the same time, I can create filters for the users so they understand where the elements are located. So if I'm planning an investment on fixing those issues, let me go back a little bit. Now I can see I selected only the elements that have a rating of 3 or below. So now I have a way to start planning this replacement, where they are located in relation to the bridge. So Posh mentioned before, you can do measurements on the web. Also in ArcGIS Pro, you can do a slice and dice of the data. In this case, I did the slice, but I excluded the beams. So I can look and see how they are, the rest of them, and see if I need to focus and replace which section needs to be replaced. Okay, so now that we have the feature services, this is what I wanna. So now I have a dashboard that tells me how the elements are in relation to each other. So for example, for the beams, I have the 3, so 4.76% of all the beams that are on the bridge are on 3. 38.1% are rated 8. Also, because I have way to connect to other system, now I have a way to the report that is generated of the general overall status of my bridge. So let's see, I replaced and I fixed this BIM. So now I can go and update it on my web ArcGIS Pro. I can update it. It updates the system on the back end. Hit play, save it. And now when we look again, the bridge, you can see that this used to be a red, now it's an orange because I have a rating of 8. So now when I do my filters and everything, this is not gonna show up. And you can see here on my dashboard, the numbers have changed and it has the rating. That's kind of the demo. I want to thank basically all these agencies and organizations that provided the data for the demos. Posh, I'm done.
All right. You stop the screen
sharing. I know it was a little bit quick, but if people want to know in more detail, feel free to contact me.
Are you seeing my big screen now, right?
Yes.
Okay. Let me just go. All right. So closing this up, the future of airport IFC. So why IFC for airports? As David had just gone through, IFC, the data in IFC is granular, so we can easily make changes and add custom attributes to it. It allows for open integration of multiple design platforms. So the graphic that I have here, all different inputs into IFC, to explore open BIM, all data under one environment. And to really push for the future of airport IFC, especially for the US, we need US airport engagement. So if you're interested to join the BIM to GIS working group or any other working group within the airport room, please reach out to myself or David. And to help us even farther, the Building Smart International Airport Entity Project team had launched an airport survey, and they're looking for feedback from airport experts to take part in this survey. The survey there's 4 surveys broken out. I myself am really focused on the civil airfield side. So I did go through that survey, and it was a really nice survey, really good feedback. Probably took like 10 minutes to go through. So your feedback will help guide and map out the future of airport IFC. And deadline for that is August 30th, and the QR code is on the screen. Or you can just go on Google or whatever search engine and type in Building Smart International Airport Survey. Next, if you want to step-by-step and more breakdown and workflows into what myself and David had gone through today, please visit the link provided below or scan the QR code. And as David had mentioned, we couldn't provide the content we provide today without the thanks of these organizations. And here is my contact information and David's contact information. If you'd like to be engaged in our BIM to GIS working group, please reach out to us. Or if you are interested in being part of the airport room for Building Smart USA, reach out to us as well, and we can forward your contact to Cindy Baldwin. She leads up the airport room. And just closing up, If you're not engaged in Building Smart USA and you'd like to, please contact Ian Howell at the email address shown, and we will host monthly webinar series on the second Wednesday of each month at 12 p.m. Eastern. And here are other ways that you can stay connected with us. With that, I will open up to Q&A.
Thank you, Posh and David, for this great presentation. We do have some questions that have come in while you were doing the presentation, and maybe we can read them to you, and you can answer for the folks. Okay?
Sounds good.
Okay, thanks. The first question is, why do we need IFC plus Revit plus geodatabase? IFC made from Revit isn't ready? Question mark.
I can take that one. The graphic that we have was just more of, it's not and, it's more or. It's different input. We don't need everything. We could use all three, but it's just more of, yes, here's an input that can be IFC. We can also do the same way, the same workflow for Revit or geodatabase. It's not a combination of all three. It's more of a pick your poison, and then it's the same workflow.
Okay, that's great. Thank you. Another question we have is how that image, sorry, not sure which image, we didn't capture a timestamp, how that image is linked and why it is needed in attribute. It is not constructed yet. How can image be linked?
So, okay, I kind of forgot to explain. So the bridge is already constructed. So it already has been there for a few years, and it already passed the first inspection. So this maybe will be the rating after the first inspection. Why we need it as a link? You don't have to have it as a link. I just like when you don't have to go and look through different tables to find the pictures, that everything is linked to the picture. I could have linked it to a repository where all the pictures are located, and that's fine. It depends on how you want to implement that section. I hope that answered your question.
Okay, if not, they'll get back to us. Another question for you. Is it possible to make changes in the BIM model by staying in ArcGIS Pro or IFC?
So the source, basically Revit and IFC, are read-only on ArcGIS Pro, so you cannot do any changes using ArcGIS Pro. You will have to use the native applications to do any changes to the digital model.
Okay, thanks. Ready for another one?
Yeah.
Thanks. Will GIS accuracy help to design the airport runway? Or do we need any data other than GIS satellite data like LiDAR or any other methods?
Posh, you want to take that one?
Yeah, I can take
now
that
that
one.
you do, that's what you do.
Yeah, that's my day to day. So you still need an established survey to make sure you have the most accurate coordinates for the proposed runway. But then you can overlay the LiDAR information and display it on GIS maps. But for project design, you need an established survey points for the runway ends.
I guess a follow-up to that question, will GIS plus BIM be useful in operation and maintenance phases, or is only BIM enough to do the same?
You want to take that one, or
Yeah, I can take a stab at that one, and then you can add on to it. It really depends on the organization on how they want to maintain their O&M. If they're GIS centric, BIM into GIS is a no-brainer. But if they have other platform, you know, and then other systems that aren't in GIS, then you can go directly from BIM. So it's more of a use case scenario. I know for most airports, they have a GIS CDE. So getting more data into GIS helps with the maintenance and operations of that airport.
Yeah, basically the same thing with Posh. It just depends on what the organization is using for their operation and maintenance. If they're focused on the GIS, yeah, you can use it. But if they're not using GIS, they can use the application that is tied to the BIM side.
Yeah, and then also just to add on that, like if we bring up digital twin, you can have different digital twin for different systems. So like an HVAC system can be read directly from the BIM model, and it's not tied to GIS at that moment. So it just really depends on the use case and the systems involved.
Okay, that's good. Thank you so much. We're scanning for other questions. I don't know if you can see the chat window, but people are thanking you. And on behalf of Building Smart USA, we would like to thank you as well for a very thoughtful and informative presentation today.
Thank you, Tony.
Thank you, Tony.